Hello students. Today we would be writing a program to calculate summation of digits of a number given by user. An example is given over here that if the user enters 754, then we'll have to calculate the summation of the digits, that is 7 plus 5 plus 4, that is 16, and have to display it on the console. So for that we have started the program with declaring a variable called num, and then have prompted the user to enter a number, and whatever user enters we are collecting it in the variable num by using scanf function. Now next thing is to calculate the summation of the digits. So for that we would be using modulo operator, and also we would be making use of integer division. So what does modulo operator do? It returns a remainder of division. So if any number is divided by another number, whatever is the remainder is returned by modulo operator. And if we do a modulo operation um, on any number by 10, that means if we if a modulo 10 operation is applied on any decimal number, then it would return the least significant digit of the number. So it is very clear, that is say if 754 um, is a modulo 10 operation is applied on this number, then it would return 4, because 750 is multiple of 10, right? 750 is multiple of 10, that is, it is fully divisible by 10. So 754, when it is divided by 10, the remainder is 4. So that is what would be returned by using a modulo 10 operation on 754. So by using modulo 10 operation, we can get the least significant digit of any number. So this would be used in this program. And other thing that we would be using is integer division. So what is integer division? In general mathematics, if we divide any number by some other number, say 11 is divided by 2, the result would be 5.5. But in C compiler, or for that matter many modern compilers, if we divide 11 by 2, as 11 is an integer and 2 is also an integer, so 11 divided by 2 would also result into a integer value, that is it would return only 5. And from 5.5, which should be the actual result by general mathematics, from 5.5, the fractional part would be truncated, only the integer part would be returned. So that is known as integer division. We would make use of integer division as well in this program. So let us first see the algorithm of the program, and then we would write the code. So the first step that we have done is to get the number from the user. Say 754 is the number that is entered by the user. Now as first step, what we would do is from this num variable we want to get the least significant digit of the number. So for that, let's say digit is a variable in which we would store num modulo 10. So num has got 754. If you do a modulo 10 operation, then this operation would return 4, that is least significant digit of the number, and that would get stored in digit. Now we would declare as accumulation variable, say sum, and initialize it with 0. And now we'll have to accumulate the digit that we have just got by using mod 10 operation on the number, and we'll have to accumulate the digit into the sum variable. So for that we would be writing this statement, sum equals to sum plus digit. So at this step because sum is currently 0, 4 would get added to 0. 0 plus 4 is 4, and 4 would get stored in sum. Now we are already done with the least significant digit, so it is no more required in the number. We want to get 5, right? So for that, what we need to do is we want to truncate 4 out of 754. That means we want just the remaining digits, that is 75. That is what we want. So for that, we would be using integer division operation. So for integer division, what we would do is we would divide the number by 10. So this is integer division because 10 is an integer and num is also an integer, right? So 754 divided by 10 in general mathematics should return 75.4, but in C compiler it would return 75. So 0.4, that is the fractional part of the number, would be truncated and only 75 would be returned. That we can store back in num, because in num we have already extracted out 4 and we have already summed it up in the accumulation variable, so it is no more required. So what we are doing is we are dividing 754 by 10, and the result, that is 75, is we are storing it back in num variable. Now these 3 steps would be repeated. So in the second iteration also we would repeat these 3 steps. So in the first step, that is num modulo 10, that we would do, because num has got 75 mod 10 would return us 5, right? So in digit 5 would get stored. Now in the second step, that is sum equals to sum plus digit, in the first iteration, because sum has got 4, so 4 plus 5 would get summed up, that is 9. 9 would get stored in sum, so sum would get a value 9. I hope you have got it, because in the previous iteration sum has got a value 4. In that we are adding the digit, that is 5 is getting added. 4 plus 5 is 9, so 9 is getting stored in sum. Now 75, num has got 75 divided by 10, that is 7.5, because it is integer division, that is it would return only 7, so num would get a value 7. So see, from 754 we have truncated 4 out and then 5 out, because 5 is already used and accumulated in the sum variable. Now this 3 steps would again be repeated third time. So we are just left with 7 in the num. So the digit that we would get by doing a modulo operation on 7, modulo 10 operation on 7, is 7. So here many students get confused that 7 modulo 10. I have many times asked students to answer this, what would be the 7 modulo 10. The answer comes out to be 0, but it would not be 0, because if you divide 7 by 10, the quotient is 0, but the remainder would always be 7. So let me write this: 7 when it is divided by 10. So as 7 is smaller than 10, it is not divisible by 10 as such. But if you see that 10 into 0 is 0, right, and the remainder is 7. So that is what would be returned if 7 is divided by 10. So 7 modulo 10 would return 7, and that is what we would store in digit. Now sum equals to sum plus digit. So in previous iteration sum has got the value 9, and then 9 plus 7, that is 16, would get stored in sum. So sum would get the value 16, and this is the result we were looking out for. 7 plus 5 is 12, 12 plus 4 is 16. So this is the result that we should be displaying on console. Now num equals to num divided by 10. So num has got a value 7. 7 divided by 10, 7 divided by 10 is 0 0.7, and from this if we truncate 0 0.7, then the integer part that remains is 0. So num would get a value 0. So here our algorithm should stop, and for that the condition that would indicate us that we should stop now is that the num would get a value 0. So this is the condition that we would be using as stopping condition in our program, right? So these are the three steps that we'll have to repeat. That means we would be including these three steps in a loop, and the stopping condition that we would be using is num equals to 0. Until and unless the number becomes 0, we would keep iterating into the loop, inside the loop, and after coming out of the loop, the sum variable would contain the result, so that we would display it on the console. So let us now write the code here. So as I said, the stopping condition is num equals to 0. So we would be using a while loop here, and the stopping condition is num equals to 0, right? So until and unless the num becomes 0, we want to keep iterating into the loop. So the condition that we would have is num greater than 0. So when this condition is true, we would keep on iterating in the loop. Now the first statement is digit is equals to num modulo 10. So we'll have to first declare a variable digit, and let me declare accumulation summation variable as well and initialize it with 0. Now digit is equals to num modulo 10. That is our first step to get the least significant digit of the number into digit variable, and then we would be writing this accumulation statement. That is, we would be adding the value of digit into current value of sum and store it back into the sum variable. So sum equals to sum plus digit. Now the third statement within the loop is num equals to num divided by 10 to get rid of the least significant digit from the number, because we have already accumulated it in the sum variable. So num equals to num divided by 10. That is what our statement should be. So these are only the three statements, those would be within the loop, and after coming out of this loop, when num becomes 0, we can come out of the loop and the result would be stored in sum variable. So that we are going to display it on the console. The summation of digits of %d is %d. So first of the %d is here, we are going to replace it with the value of num variable. But see, the num variable has already become a 0. So if we are going to use num variable here, then we are going to get a 0 over here. So what we would do is we would declare a temporary variable in which we want to store the value entered by user, right? So initial value of the number is stored in the temporary variable, right? Because we are manipulating the num variable, even though it initially contained the number entered by the user, but as we are dividing it by 10 again and again until and unless it becomes 0, so when the control comes here, the num would get a value 0. So if we replace it by the value of num, here we would get 0. So that is not what we want to get. The summation of digits of the initial number, that is the number entered by user, has to be printed over here. So for that we would be using temp variable, and here we would output the value of sum variable, which currently contains the summation of digits. Now we would end with get function. So let us build it. We are done with the program. Let us build it and see that if our program works correctly or not. So it has built correctly. Now run it. It is enter 754. The summation of digits of 754 is 16. So it is working correctly. Let us run it one more time to see if it is working for other inputs as well. So 1 2 5 5 6 1 2 5 6. Now summation of the digits of 1 2 5 6 is 14. 1 plus 2 is 3, 3 plus 5 is 8, 8 plus 6 is 14. So our program is working correctly and our algorithm is correct. So this is what uh, um, our program is for this problem. Okay, thank you.